Okay, we've created a new RPC here. And as always, let's change this thing first, otherwise we'll forget it later. Let's add the Vpredict first, and then add the header file. To add the header file, let's copy one over first. Okay. Then let's simply send out these 3 RPCs first. Send them out, then we'll expand. First, let's go directly to this position. Take a look at this method. Okay. And here it seems we need to specify whether it's reliable or unreliable. Let's set them all to reliable for now, because we'll make them reliable. Okay. Let's think about how to call this method appropriately. Let's think it through. Okay, it seems we need to add this as well. Let's first create the implementation. First, make sure it compiles successfully. Okay. Then, first of all, this definitely won't compile because it needs to have an implementation suffix. Let's add the suffix. Okay. Of course, this function can take parameters. Let's compile it first. Okay, so let's see if we can add it to Blueprint. Add a blueprint callable so that blueprint can call it. This way, we can test it easily. Let's compile it again. It's done. Then let's expose it to Blueprint. This method. Okay. Then let's add another parameter. We'll give one from the client. This parameter will call inAddHealth. That is, the client calls the server to increase this health value. That is calling. This is the SOA side. This is a server-side call. Then execute the health value on the client. And this is the client-side call. Increase health on the server side. Then we give this one ADD plan. And then here is the actual ADD called the health increase on the client. So this is where we broadcast the health increase. Then we take this parameter, copy it to our same file. And then here, we pull a health value over here. Pull a health value over. Let's go back here. This is the health value we need to use. Make it protected. Then in the constructor, let's give it a 100. Okay, then we need to rewrite this replication function. Right. Let's create the implementation of the replication function. As for our replication function, we'll use this one. Let's use a simpler one. We'll use this. We'll just let it replicate. And here we need to change this. Okay, so this function means that first, the server wants to add health, and the client wants to add health, but it cannot directly override the server's variable, so we need to control it through RPC. So we use this function to jump to the server. Then on the server, we make a judgment. For example, we directly give a health and let it equal health plus this immo keys health. So actually at this point, we know that this is where the server has changed, but the right location on our server side. The service health value has changed. Then we need to add this planned health value. Then we give it. For example, we subtract another 10 points from it. Subtract 10 points. For example, if we say 20, it actually only adds 10 points because our server has calculated. That is, there is currently this difficulty or something like that. We actually only add these 10 points. Then we can call this clean RPC, such a function. Okay, we put this value in, and the client should receive this value. Then we call this broadcast RPC. Then all clients will receive such a value. Okay. Then after we receive this value, we need to process it. We can have it print this logo. Yes, we prepare a logo to print. Obviously, this is on the server side, right? We put this logo here. For the duration, let's make it a bit longer. Let's give it 20 seconds, and we'll use red for the color. Not the server. For the server, take the ADD health we received. Yeah. One is the server. Okay, so add health. Okay. Then let's print this information. And here, this is our client. This is our client. This is actually our Owen client. This is the information received by the Owen client. Let's put this here. Okay. And here. So this is the mute received via broadcast. All clients will receive this information. Okay. Good. Now let's execute this method. We see there is a sweep here. Clear. This is an RPC. Because we actually wrote it for you before. We said we didn't write it separately for him. Okay, now let's call and execute it. We made it a bit convoluted here, but it shouldn't affect anything. And then, regarding this part, as for this object, it is not a character, so we need to set its owner. Otherwise, it won't know that its client end is connected to its host proxy role. On each machine. Okay, so here, we create a new map. We'll use 008 零用位 artifact. We create a new map. Okay, so like this, and here, we'll call it level RPC. Put it here. Then we create a blueprint child. Here, BP. Then put it here. Then put it in this place. After placing it, we'll leave it for now. Leave it for now. Here we are. We can drag one in. But this time, we won't drag it that way. Why not drag it that way? Because dragging it in that way, it will definitely have a stable name because it's something that already exists in the level map. Doing it this way should also be fine. But we still prefer to do it this way. We'll do it this way. In begin play, we still need to check. We need to do this on the server. On a dedicated server. Okay, so let's add a delay first. Let's delay for 1 second. Because we might need to wait for the client to log in. Okay, after the delay, we will active from class, and then we select our RPC class. It should be BPXG That should be it. Okay, we select it. Then here we will have an owner. We select the first get. Because now it's on this server, we get an owner from the first player controller. This provoker should be fine. We should set it to the same. That works too. But it seems to need to be cast to a pump object. We'll ignore it. We can give it get control pump. That should be enough. Okay, the spawn location needs to be controlled. We just spawn it at the mouse origin. After spawning, we call its RPC. We should be store. We are on the server now, so here we are on the server. This thing is actually then we directly call mute. This will directly call the broadcast. Let's check. Let's call a water. Let's execute it now. Let's open 2 instances. You can see that this group of broadcasts has been received. No issues. Then pay attention to this place. It seems there is a bug here. Let's check what this bug is. Let's look at this log here. It actually accessed an unknown get player controller. It might not have obtained this get player or this controller here. Let's extend the time a bit more. Let's try it again. You can see here it executed this multi-client function. Essentially, that is to say, it is actually equivalent to our broadcast. It is actually on our server. On both of our clients, it actually executes on both. You can say, we set A to 1. Set it to 1. Right. So this should be, it executes on both the server and the client. So how do we verify it? We can verify it like this. We add a condition here. We still do it by typing. We might need to get the git mode from a TIC here. If we are on a dedicated server, we give it a warning log. And here, we give it a warning level. This is the service, this is the server. It received the broadcast. Okay. And then we change this to the client, one by one. This is the client receiving the broadcast. Now let's execute it again. And now we have started. Our code here is still like this. It's as if we haven't changed the map. Switch the map over. We are here in the level blueprint. We spawn an actor and we set its owner. Then we call its broadcast function. Now let's execute again. Okay, let's check our log. Obviously, the server here executed the broadcast function. The client also executed the broadcast function, right? Now, if we open 2 instances, then obviously this sign should be 1 server plus 2 clients. Okay, so this input is correct for easier verification. Let's write a blueprint. Broadcast event here. Let's write a custom event here. Alright, here set it to broadcast. Then we give it a name called mute. Mute beeped. We print the log. Broadcast, blueprint, broadcast. Of course, it can also pass parameters. For example, we pass 1 here. This definitely has no return value. We'll just give it an int. Then in the level blueprint, I will call it. We also call it through this actor. We call it mute BP, then OK. We gave it a 0, and now we execute it again. OK, this proves that our blueprint and the client are consistent here. You can see it. Of course, we can check this option here to make it reliable. Let's make it more stable. Okay, you can see here that server and client has no issues at all. which proves that our broadcast is fine. Next, we will disconnect this part. We won't test this broadcast anymore. Now, we will remove this server. Server replication. Obviously, we can only remove the server replication on the server. For example, we pass it 1. Okay, let's execute it now. Let's open one, open two, open one first, open one first, okay? Okay, you can see. This is a broadcast, right? Because we are in the server, it will call a broadcast here. So we don't need to verify this broadcast. We mainly look at this client. You can see this client. We are here. Owen client executed this, right? This is a broadcast. We don't need to look at these two broadcasts. The server executed this. That means we call this to the specified client. Then we can here split it into two. You will notice here on the Owen client, this one is broadcast. This mute is all broadcast. No need to look. So this proves that this function, what does this prove? It proves that when you call this function, it first executes this thing on the server. Then this thing is called to execute at this location on the specified client. So let's take a look at how we write it using blueprint. Here, we have a customer event. Okay, we give a blueprint, then we give a client. This is to be executed on the specified client. But we can also pass parameters here. We don't need to worry about the parameter passing issue. Then here, we need to make it reliable to avoid some problems. We need to execute it on the specified client. As for this specified client, let's type it. This is called client. What we see is the server calling the specified client to execute. The server calls the specified client to execute. Okay. After writing this part, we will call it in the blueprint. So here, it should be plant this. Okay, now let's learn by comparison. Okay, then we execute it here. You can see there will only be one here. Let's make this a bit longer. Make it a bit longer. Let's extend the ringing time. Let's set it to 20. It will only execute on its own in its place bars. It can be seen. This is our server calling the specified client to execute. You can see that it only rings once here. Right, it only executed once. That's what it means. Correct. You might say, is there a bit of interference here? You will notice, why does it also appear on the screen? That is because of the current debug mode. We can change it. Let him go. No longer run under one process. Let's test it this way, so everyone can see it more clearly. This time we might need longer. Let's take a look. Look at the result of this direct signal. It seems stuck on my end. Let's check. Something might be stuck here. Let's handle it first. Kill it. Let's restart it. Then you can see that here our machine will print, but our interface will not print, because actually we have an interface. I'll turn this off. We can do it like this. We use the editor. This way it's clearer for everyone. Okay. There are two windows, right? You can see, actually, we only have one window printing in blue. This one proves that it is only executed on our first client. The other client only received the broadcast. You can see. You will notice there is a difference between these two prints. This makes it very clear, because here it's equivalent to let's see if we close it. So regarding this function of ours, here, this client, it will only execute on our client side. Then the function inside this server, it will call this client. It will print a red message like this. So on our side, the red one, it consists of two messages. One is the message called from this location. This part is a bit confusing. Everyone sort it out. This message was printed when our player 1 went up. Then here in our place, his message was also printed when our player 1 went up. Our player 2, he will actually only receive a broadcast of this message. The broadcast of this message, so our player 1 has 3 messages. Our player 2 only has 1 message. Player 2 will only receive the broadcast of this message. And our player 1 will both receive the broadcast. And also receive a client TOP. One is a client RPC written in C++. One is a client RPCs written in our blueprint. Then let me show everyone again. This part is a bit confusing. So let everyone take a look. Test more and write more. Here you can see, look at our player 2. One message is received, and our player 1, he receives 3 messages. One is from our C++ client. One is from our blueprint client. One is from our C++ broadcast. And the player 2 only receives the C++ broadcast. So this is quite clear. Okay, now let's exit it. Now we mainly demonstrate. Let's go ahead and demonstrate it now. That is to say, let's see what else we haven't demonstrated. How do we demonstrate this? How do we call this client RPC? Because when we called it just now, we actually called it in this way. It's a bit roundabout. I deliberately wrote it in a roundabout way here. Okay, let's see how we call this. We implemented it through key binding before, and we can actually do it like this. First of all, let's go back to our project. Let's change the spec first, because starting it this way is too slow. We need to test it within a single process. Then we do it like this. Here, we are on the client. We are on the server to do this. The server will spawn this object after 2 seconds. So we set up a key binding. We use a keyboard. Okay. That is, when we press 1, we first need to check if we are on the server. Check if we are on the server. Okay. Alright, this part is actually executed on the server. RPC. The correct way to use it is to execute RPC like we are doing here. Then we can do it like this. Get actor of class. Because I know there must be such a class in our scene. It should be BPRPC. Okay? There must be such a class in our scene. We should be able to get this class. We are currently on this client. So it should be this one. When we press this key, if it is available, then we just call this method. This is the correct way to write it. The correct way to write it is like this. Okay, so this way our filing is correct. Then we can go ahead and adjust it now. We just need to wait a moment and then we can adjust it. Now let's say for example here, right? Hey, this place is showing a prompt. This lower right collection character PK function server BP refraction will not be processed. That's very simple. Why is this the issue here? Can you figure out the answer? Did we write something wrong? So I am now executing in this window. What if I execute in this window? Can you get my point now? Do you understand what this means? Then let us introduce the answer. It is because of this. It is because of this. This owner belongs to player 1. If we send it from player 2, then this will not work. This will be incorrect because you are in the world of player 2. And you are modifying something belonging to player 1 if you are in player 1's world. And you do this thing. That's it. It's okay. Can you get this point? Then we can take a closer look. Sedona, that's your first reaction. Is it that this owner was not set, but we set it right from the start on this side? You can see the set owner parameter. This owner is network replicated and synchronized. When the server changes it, other clients will receive it. So in fact, this object of ours currently belongs to player 1. Therefore, when player 1 calls this RPC, the save is RPC. That is reasonable. You can see, right? Let's execute it again. This is because there are many things in front of us here. We can disconnect the previous series. This way everyone can see it more clearly. You can see this information. So actually this information here, we just press 1. So actually we are in World 1. We sent a server RPC, then at this server RPC, here, right here, we first printed a server log, then we executed a client RPC, then executed a multicast RPC. This client will beat Owens, then the multicast will beating 3 broadcasts. You can see here. Let's turn it off. Here, execute it in here. There are 5 messages in total. So, do you understand how these 5 messages came about? That is, you should be able to know how these 5 messages came about. You can see these 5 messages. First, these 3 messages printed to the screen are from this place. There is one here. This place. First, there is one piece of information here. Then, the client has one piece of information here. Then, the broadcast has 3 pieces of information here. Then, in the log, there are 3 pieces of information, because all servers and clients will execute it. Okay, let's take a look over here. Have we covered everything? We should have covered everything. Maybe we still have a server here. Let's write the server. Let's give it a server. Actually, I personally like to write it this way. I call it client server. I like to write it this way. This way I can clearly know what is going on with it. So obviously this event is one that executes on the server and is called using mutual invocation. Actually, my personal way of writing this is called server call client. Yes. And then I like to mute it like this. Mute, let's just call it mute. And then here, we give it a log saying client call client. Okay. So how do we execute it here? We need to execute it in the same way. This spot is a bit tricky because here we won't execute this. So we execute the server. Server client call server. Okay, then when we press 1, it can execute smoothly. Let's check the result. It seems we made a mistake somewhere here, right? I didn't connect this line. I didn't connect this line in the wiring. Let's take a look. You can see this part is executed on the server, right? There shouldn't be any issues. Okay, then let's end this lesson here. Because it's a bit convoluted. That's my fault. Sorry about that.